What in the universe can swallow a star whole and yet remain invisible? Out there in the silent darkness of space exist cosmic monsters that emit no light, cast no shadow, and can devour anything that dares to get too close. We call them black holes, and they are far stranger than anything science fiction has ever imagined. Black hole is not really a hole. It's a region of space where gravity is so intense that nothing, not even light, can escape. At the very heart lies the singularity, a point of infinite density where the laws of physics, as we know them, simply break down. Surrounding it is the event horizon, the point of no return. Once you cross it, there is no coming back. Imagine space-time as a stretched sheet of fabric. Most objects, like planets or stars, create dents in the fabric. But a black hole, it punches right through. Most black holes form when a massive star runs out of fuel and collapses under its own gravity, triggering a spectacular explosion, a supernova. The core that remains is crushed into a black hole. There are also supermassive black holes, millions or even billions of times heavier than our sun, sitting at the centers of galaxies. How they form is still a mystery, maybe from countless mergers, maybe from enormous clouds of gas collapsing in the early universe. Close to a black hole, the rules of reality start to warp. Time itself slows down because of extreme gravity, a phenomenon known as gravitational time dilation. From the outside, it would seem as if you're frozen at the edge of the event horizon forever. But for you, the fall would happen in seconds. Then there's spaghettification, the terrifying stretching of matter caused by the difference in gravity between your head and your feet. Black holes don't just bend space, they twist time into unimaginable shapes. In 1974, Stephen Hawking made a shocking prediction. Black holes aren't completely black. Due to quantum effects, they slowly leak energy in the form of Hawking radiation. This means that over unimaginable timescales, black holes can evaporate and vanish. For small ones, this could happen quickly, but for giant black holes, it would take longer than the current age of the universe. At the heart of the Milky Way lies a supermassive black hole known as Sagittarius A, with the mass of about 4 million suns. We can't see it directly, but we know it's there, from the way nearby stars whip around it at incredible speeds. In 2019, the Event Horizon Telescope gave us the very first image of a black hole's shadow from a galaxy called M87. Sometimes, two black holes spiral toward each other, merging in a colossal burst of energy. When that happens, they send ripples through the fabric of space-time, gravitational waves. In 2015, the LIGO Observatory detected such waves for the very first time, confirming Einstein's century-old prediction. We can even hear these waves when they're converted into sound, a brief cosmic chirp from billions of light years away. There's a common myth that black holes act like cosmic vacuum cleaners, sucking in everything in sight. The truth? If our sun were replaced by a black hole of the same mass, Earth's orbit wouldn't change, we'd just freeze in the dark. In science fiction, black holes are often gateways to other universes, or time machines. Theoretically, wormholes could connect distant points in space-time, but whether they can exist or be stable is an open question. And then there's the idea of white holes, the hypothetical opposites of black holes, which spit matter out instead of pulling it in. Black holes are like locked doors in the cosmic mansion, doors we cannot yet open. But beyond them may lie answers to the greatest mysteries, where the universe came from and how it might end. The deeper we look into the darkness, the more we learn about the light and about ourselves.